Hello and welcome back. However you got here tonight, let yourself arrive fully now. Let your shoulders drop a little further into whatever is holding you up, whether that's a bed, a couch, or just a comfortable chair. Let your breath slow down in gently through the nose, out long and unhurried, and let whatever the day asked of you begin to loosen its grip, one slow breath at a time. Right now, beneath wherever you happen to be resting, and beneath nearly every patch of soil on earth, there's something vast, ancient, and quietly alive that most of us never think about at all. It isn't a plant, and it isn't an animal, though it's genuinely closer kin to you than to any tree. Tonight, we're going to follow that strange, patient kingdom of life all the way from a common ancestor it shared with us more than 1 billion years ago, through Ice Age hunters, pharaohs, poisoned emperors, terrified villages, and a healer whose kindness cost her everything, all the way to a single living organism so large it would swallow a small town. You don't need to remember any of it. There's nothing to solve here tonight, no test waiting at the end. Only a long, slow walk through a history stranger and older than almost anything else we've ever covered. Let your eyes rest closed if they haven't already. Let your breathing settle into its own natural rhythm. And let's begin the way this particular story actually begins, not with the first human, not even with the first plant, but with a single ancestor life form, splitting quietly into 2 very different destinies. Somewhere around 1.5 billion years ago, in the deep, slow currents of early evolutionary history, a single lineage of life split into 2 branches that would go on to look almost nothing alike. One branch eventually gave rise to every animal that has ever lived, including us. The other gave rise to fungi. It's a genuinely surprising fact, one worth sitting with for a moment. Mushrooms are not plants, whatever a produce aisle might suggest. Fungi don't photosynthesize, don't build their bodies from sunlight the way a plant does. Like animals, they survive by absorbing nutrients from whatever's around them, which makes a mushroom, biologically speaking, considerably closer to you than it is to the tree it might be growing beside. That kinship shows up in stranger, more tangible ways than diet alone. The tough, structural material that builds a mushroom's cell walls is called chitin, the very same molecule that builds an insect's hard outer shell and a crab's shell alike. No plant on earth builds itself out of chitin. It's a chemistry fungi share specifically, and only with the animal kingdom. One more quiet piece of evidence, sitting right there in a mushroom's own cell walls, that the produce aisle has been sorting things wrong all along. Finding physical proof of something this old is never simple, and fungi have left behind a genuinely scattered, still debated fossil trail. The clearest, most widely accepted early fungal fossils come from rock in the Democratic Republic of Congo, dated to somewhere between 700 and 15 million and 810 million years old. Other, more contested finds push the story back even further. Mineralized filaments in Canada, suggested to be roughly 1 billion years old, and mysterious mycelium-like structures found threading through ancient lava rock in South Africa that some researchers date to an almost unbelievable 2.4 billion years. That South African claim in particular remains genuinely contested among scientists, and it's worth saying so plainly rather than presenting it as settled fact. If it holds up under further study, it would place fungi among the very oldest complex life forms ever identified on Earth. Older than nearly everything else this whole story is about to cover combined. Even the more conservative, better supported dates still place fungi on the scene enormously earlier than familiar land plants or animals, quietly present through unfathomable stretches of time before anything resembling a modern forest or a modern human ever existed. Long before there was anything you'd recognize as soil, fungi were quietly building it. Early fungal networks excreted enzymes and acids capable of literally breaking solid rock apart, patiently converting bare mineral surfaces into the first genuinely fertile ground this planet had ever known. That slow, mostly invisible labor is, in a very real sense, the reason anything else was ever able to take root here at all. Plants didn't colonize dry land through their own strength alone. They arrived to find fungi had already spent unimaginable stretches of time quietly preparing the ground to receive them. Much of that earliest pioneering work wasn't carried out by fungi acting entirely alone either. Lichens, those crusty, often colorful growths still found clinging to bare rock and tree bark everywhere today, are themselves a partnership between a fungus and a photosynthesizing algae or cyanobacteria, and among the very first organisms of any kind capable of surviving directly on bare, exposed stone with no soil to root in at all. Long before a single blade of grass existed, lichens were already slowly grinding rock into dust, one microscopic foothold at a time. The same essential head start fungi alone were providing everywhere else across the ancient landscape. Even once plants did arrive, most of them still couldn't have survived on their own. Early mycelial networks, the fine underground threads that make up a fungus's true body, wrapped themselves directly around the roots of the earliest land plants, trading minerals and water the plant couldn't reach by itself for a share of the sugars the plant produced from sunlight. It's a partnership that never really ended. The overwhelming majority of plants alive today, including nearly every tree in nearly every forest, still depend on that same essential fungal partnership underground, whether anyone standing among them ever notices it or not. It's worth understanding, too, just how small a role the visible mushroom itself actually plays in a fungus's real life. What most of us picture when we hear the word mushroom, the cap and stem pushing up through soil or bark, is really only a brief, temporary fruiting body, the fungal equivalent of an apple hanging from a tree, produced specifically to release spores before quietly withering away again within days. The organism's actual body is the mycelium, that same fine underground network of threads, often persisting for years or centuries in complete silence, only occasionally sending a visible mushroom up into the light when conditions of temperature and moisture happen to align. By around 400 million years ago, during the period geologists call the Devonian, fungi weren't simply working quietly underground anymore. They were, for a genuinely strange stretch of Earth's history, the tallest living things around. Towering structures called prototiacacetes rose as high as 8 meters, trunk-like columns standing alone across a landscape that had no proper trees yet at all. An almost unimaginable image, an organic skyscraper of fungus, casting the only real shade on an otherwise low, barren world. The tallest plants sharing that same Devonian landscape stood barely a meter high at most, meaning prototiacacetes wasn't simply the tallest fungus of its era. It was, by a genuinely enormous margin, the tallest living organism of any kind then found anywhere on the entire planet. When fossilized remains of prototiacacetes were first uncovered in the 1800s, the geologist John William Dawson took one careful look and confidently declared them the rotted remains of some giant ancient conifer tree, an entirely reasonable guess at the time, and an entirely wrong one. It would take considerably more sophisticated chemical analysis, more than a century later, for modern researchers to finally confirm what Dawson had no way of knowing that this ancient giant hadn't been a tree at all. It was a fungus, standing taller than most buildings humans would build for millennia afterward. Even that correction hasn't entirely settled the matter. In the interest of full honesty, a small number of researchers still argue Prototiacacetes may not have been a pure fungus at all, but some now extinct lichen-like partnership between a fungus and a photosynthesizing organism. A genuinely open scientific question about a genuinely bizarre organism that stopped existing long before anything with a spine ever crawled onto dry land to ask it questions. Not every clue about that ancient partnership had to survive the ordinary violence of fossilization either. In the Scottish village of Arwine, a patch of ground once sat directly beside an active hot spring roughly 407 million years ago, and the same mineral-rich water that made the site inhospitable for most life also worked as a remarkably gentle preservative, flash freezing an entire ancient wetland ecosystem in fine-grained silica before ordinary decay ever had the chance to erase it. The resulting rock, now called the Arwine Chert, captured some of the very earliest primitive land plants ever found, preserved in such fine three-dimensional detail that researchers can still see, under a microscope, the actual fungal threads wrapped around their roots, exactly where they were doing their ancient work the moment the hot springs minerals sealed everything in place. 65 million years later, fungi found themselves perfectly positioned for an entirely different kind of moment when an asteroid struck Earth and triggered the mass extinction that ended the age of dinosaurs. The resulting debris cloud blotted out the sun for years, killing off the overwhelming majority of plant life across the entire planet in what amounted to a genuine nuclear winter. Fungi, which don't need sunlight to survive in the first place, thrived on exactly the kind of decomposing organic matter that catastrophe left behind in staggering quantities. Researchers studying the genetics of psilocybe, the genus that includes what people today casually call magic mushrooms, believe this same grim, fungus-friendly window is roughly when that particular lineage first branched off and began its own long evolutionary story. That same basic talent, thriving on what everything else leaves behind, never really stopped being fungi's quiet specialty. Without decomposers patiently breaking down dead wood, fallen leaves, and animal remains back back into their basic chemical components. Those nutrients would simply stay locked away forever inside whatever had died. And the entire cycle feeding new plant growth would grind to a halt within a few short seasons. Every forest still alive today depends on that same unglamorous fungal labor, constantly, quietly recycling death back into the raw material of new life. Fungi's long relationship with humanity itself begins considerably later, but still reaches back much further than most people would guess. In Spain, archaeologists studying the 18,700-year-old remains of a Paleolithic woman researchers have nicknamed the Red Lady found traces of mushroom consumption still preserved in the calculus built up on her ancient teeth. Direct physical evidence that Ice Age foragers were already deliberately eating mushrooms as part of an ordinary diet. Tens of thousands of years before anyone would think to write a single word about them. A considerably more famous ancient body left behind an even more specific clue. Uatsi, the naturally preserved iceman who died in the Alps roughly 5,300 years ago and was discovered frozen in glacier ice in 1991, was found carrying what researchers have come to describe as a genuine prehistoric first aid kit. Among his belongings were two distinct types of fungus, carried for two entirely different, deliberate purposes. One was a tough, leathery tinder fungus, Fohmes fomentarius, dried and prepared specifically to catch a spark and help start a fire. A small but genuinely essential piece of survival technology for anyone traveling through the cold, exposed high Alps. The other was a birch polypore, Piptioh betulwinus, a fungus known to carry real antibacterial and mildly toxic properties, and researchers studying Uatsi's remains have found evidence he was suffering from intestinal parasites at the time of his death. Strong circumstantial evidence that he was carrying this second fungus specifically as medicine, treating himself with exactly the tools available to him. More than 5,000 years before anyone had a word for antibiotics. Both fungi still grow on birch and beech trees across the same mountains today, essentially unchanged from the specimens Uatsi carried, meaning the exact same species he relied on for fire and medicine more than 50 centuries ago remain available to anyone willing to look closely enough at the right tree. Fungi's earliest medical career wasn't limited to Uatsi's own small alpine first aid kit. either. Across widely separated cultures, with no contact with one another, from various indigenous peoples of North America to rural healers throughout medieval Europe and traditional practitioners in China, the dry, powdery spore mass inside a mature puffball mushroom was independently discovered to help slow bleeding when pressed directly against a wound, a genuine styptic effect modern chemistry has since traced to natural compounds within the spore mass capable of encouraging blood to clot. It's a small, practical piece of folk medicine that shows up again and again in the historical record for exactly the same reason ergot and penicillin do real fungal chemistry, quietly doing real work long before anyone could explain precisely why fungi's presence in ancient human life shows up in art as well as in teeth and travel kits. In the Ta'esi-Ili Nahshur Mountains of Algeria, a vast, remote sandstone plateau now surrounded by the Sahara, but considerably greener when these images were first painted. Rock paintings dated to somewhere between 7,000 and 9,000 years old appear to depict human figures holding mushroom-shaped objects, some seemingly emerging directly from the figures' own bodies, in scenes many researchers interpret as early depictions of ritual or shamanic trance. Comparable rock art in Spain, dated to roughly 6,000 years old, and separate rock art in Australia, dated as far back as 10,000 BCE, suggest this same basic pattern. Humans deliberately altering their consciousness with fungi and finding the experience significant enough to paint onto stone, playing out independently across wildly separated corners of the ancient world. It's worth picturing that Ta'esi-Ili Nahshur landscape honestly, since today's stark, waterless desert gives entirely the wrong impression of the world its ancient painters actually lived in. Climate researchers have confirmed that during what's now called the African humid period, roughly spanning 10 to 5,000 years ago, the entire region was a genuine green savanna dotted with lakes and grazing herds, meaning the same artists who painted mushroom ceremonies onto these cave walls were living somewhere considerably closer to open grassland than to the harsh, sand-swept desert that would only swallow the region many centuries later. None of these rock art sites come with a caption explaining exactly what their painters believed was happening to them. And it's worth being honest about that uncertainty rather than overstating it. What each of these separate, disconnected sites does share is a consistent pattern. ordinary people working independently of one another across thousands of miles and thousands of years, all deciding this same category of organism was worth depicting at the center of something sacred. For all that early familiarity, humanity took a remarkably long time to work out what a mushroom actually was. Even the great 18th century Swedish naturalist Carl Linnaeus, the very scientist who gave the modern world its whole system for classifying living things, confidently filed fungi away as a strange, imperfect category of plant. That classification held for generations, repeated by scientist after scientist until modern genetic sequencing finally settled the question with real certainty. Fungi aren't plants at all, misfiled for centuries by simple visual habit. They form their own entirely distinct kingdom of life, one that, as it turns out, sits genetically nearer to the animal kingdom, our own, than to anything green and rooted in the ground beside them. Fungi finally received formal recognition as their own separate kingdom only in 1969, when the biologist Robert W.I.T. Ucker proposed a revised five-kingdom system of classifying all life on Earth, correcting a mistake that had stood essentially unchallenged for roughly 200 years. Long before that formal correction, though, one 19th century Swedish mycologist had already dedicated his entire career to studying fungi seriously and systematically on their own terms. Aleas Fries spent decades cataloging and classifying thousands of fungal species during the early 1800s, developing organizational systems still recognizable in modern mycology today, and earning, among later generations of researchers, the informal title of father of modern mycology, quietly laying the groundwork for the kingdom Whitaker would eventually make official. Amateur enthusiasts organized themselves into dedicated scientific societies not long after, formalizing the same patient hobby thousands of citizen scientists still practice with smartphones today. The British Mycological Society, founded in 1896, grew directly out of informal Victorian fungus foray excursions, groups of enthusiastic amateurs and professional botanists tramping through the countryside, together identifying and cataloging specimens, evolving over the following century into one of the world's oldest and most respected professional mycological organizations. One of that same era's most careful amateur mycologists never received the recognition her work deserved, and it's worth pausing on why. Beatrix Potter, decades before she ever published a single children's book, spent years producing hundreds of remarkably precise scientific watercolors of fungi and conducting real, patient experiments on how their spores actually germinated. In 1897, she completed a serious paper on the subject, and because the Linnean Society of London didn't yet admit women to its meetings, had to have it formally presented on her behalf by a male family friend rather than read it herself. The paper was never published, and Potter, discouraged, largely turned her attention elsewhere, toward the illustrated children's stories that would eventually make her famous instead. The Linnean Society issued a formal posthumous apology for how she'd been treated only in 1997, exactly 1 century later. A quiet, considerably overdue acknowledgement that one of the era's sharper mycological minds had been dismissed for no better reason than her gender. Even now, with fungi finally sorted correctly, most of the kingdom remains genuinely unknown territory. Scientists estimate that somewhere between 2 and 3 million distinct fungal species exist on Earth, and formally described, catalogued, and named perhaps 5% of them so far, meaning the overwhelming majority of this entire ancient kingdom, the one that built the first soil, grew taller than the first trees, and gave the world penicillin, is still sitting out there, completely unnamed, waiting for someone to notice it. Even Whitaker's careful 1969 correction didn't settle every lingering case of mistaken identity, and one persistent mix-up is worth clearing up honestly. Slime molds, strange, often brightly colored organisms that creep slowly across rotting logs and forest litter, look enough like fungi, and were classified as fungi for long enough that plenty of nature guides and casual observers still lump the two together today. Genetic analysis has since shown slime molds actually belong to an entirely separate branch of life altogether, more closely related to amoebas than to true fungi, capable of surviving as thousands of individual single cells before merging into one large, slowly crawling organism when conditions call for it. It's a small, ongoing reminder that sorting life into tidy categories has never been quite as simple as it looks from the outside. This same ancient kingdom included. Closing even a small fraction of that gap has recently become an ordinary weekend activity for thousands of amateur naturalists. Citizen science platforms like iNaturalist, which has logged millions of fungal observations from ordinary users since its founding, and dedicated identification apps now let anyone photograph an unfamiliar mushroom on an afternoon walk and upload it for identification, contributing genuine, usable data to researchers who could never hope to survey every forest floor on the planet themselves. An old, patient kingdom of life, finally being catalogued by exactly the same crowdsourced curiosity that once painted it onto cave walls in the first place. Formal institutions have taken up a more permanent version of that same cataloging effort. 2. Fungal culture collections and spore banks maintained by universities and research institutions around the world preserve living samples of thousands of documented species in climate-controlled storage. A genetic insurance policy, not unlike the seed vaults built for food crops, protecting this same ancient, still largely unmapped kingdom against the possibility of losing species science hasn't even finished describing yet. Even after fungi were recognized as something worth studying seriously, exactly how they reproduced remained a genuine mystery for a startlingly long time. Ancient Roman and Egyptian naturalists had assumed mushrooms simply sprang up spontaneously from the earth itself, conjured directly out of rot, or deposited fully formed wherever lightning happened to strike the ground. It wasn't until the early 1700s that the Italian botanist Pierre Antonio Micheli finally demonstrated the real mechanism under careful, patient observation that mushrooms reproduce through microscopic spores, scattered invisibly on the wind. The same quiet, patient method still responsible for every mushroom that will ever grow after tonight. Some species make that invisible process briefly, wonderfully visible. A single mature puffball mushroom can hold several trillion spores inside its round body and needs nothing more dramatic than a single falling raindrop or a curious footstep striking its papery outer skin to release a small, sudden cloud of them into the air at once. A silent, patient population explosion most people only ever notice by accident, kicking one open on a walk through the woods. Nowhere did that quiet relationship between people and fungi grow more elaborate or more sacred than in ancient Mesoamerica. For thousands of years, the Olmec, Zapotec, Maya, and later the Aztec peoples of what's now Mexico and Central America incorporated psilocybin mushrooms directly into religious life, carving stone effigies of mushrooms that still survive today, and calling the mushrooms themselves teonanahkat, a Nahuatl word, usually translated as flesh of the gods. These mushroom ceremonies weren't casual, and they weren't recreational in any modern sense. They were treated as a genuinely serious religious technology, a deliberate, ritually guided way to commune directly with the gods, seek guidance, and according to surviving accounts, even diagnose the cause of an illness troubling a member of the community. Spanish missionaries and chroniclers arriving after the conquest, most notably the Franciscan friar Bernardino de Sahagún, documented these ceremonies in real ethnographic detail, describing sacred mushroom rites still very much alive among the peoples they were simultaneously working to convert. Sahagún's resulting work, the Florentine Codex, ran to 12 full volumes compiled with the direct help of indigenous Nahua scholars and illustrators, and stands today as one of the single richest surviving records of Aztec life, an unlikely, deeply ironic gift from a colonial mission that spent its other hand actively working to erase the very culture it was so carefully documenting. Physical evidence of that same reverence survives from long before any Spanish chronicler ever set foot in the region. Archaeologists working across the Guatemalan and Mexican highlands have recovered hundreds of carved stone mushroom effigies, some dating back more than 2,000 years, many featuring a small human or animal face carved directly into the stem. A lasting, deliberate record of exactly how central these ceremonies already were to Mesoamerican life long before the written accounts Sahagún later collected. Spanish chronicler accounts describe teonanahkat being served at the grandest, most consequential Aztec state occasions, including, according to some records, the coronation feast of the Emperor Moctezuma himself, placing this sacred fungus at the very center of imperial power rather than at its margins, a substance important enough to help formally crown a ruler of one of the largest empires the Americas had ever seen. Aztec religious tradition associated the mushroom ceremony closely with Xochipilli, the god of flowers, art, and ecstatic states, a surviving stone statue of whom, discovered near the base of the volcano Popocatépetl, is carved from head to foot in stylized depictions of psychoactive plants and mushrooms, a permanent, deliberate monument to exactly the kind of sacred experience Spanish missionaries would later work so hard to erase. That same colonial encounter that preserved the ceremony in writing was also what nearly destroyed it. Spanish religious authorities viewed the mushroom rites as a direct, intolerable rival to Christian worship, and violently suppressed the practice across the decades following conquest, driving what had been an open, communal tradition underground, kept alive quietly in remote mountain villages for centuries, far from any watching colonial eye. Ancient Egypt developed its own, considerably more exclusive relationship with fungi. Egyptian tradition held that mushrooms were a gift from the god Osiris himself, quite literally the plants of immortality, and pharaohs are said to have hoarded them jealously as a royal privilege. Ordinary Egyptians were legally forbidden from so much as touching a mushroom, an entire category of food, placed permanently out of reach of anyone who wasn't already sitting on the throne. Historians studying this particular tradition have suggested a fairly practical motive lurking underneath the religious explanation, that keeping mushrooms mysterious and forbidden made them a genuinely effective tool for reinforcing exactly how far a pharaoh stood above everyone else. A small fungus turned into a very deliberate, very visible symbol of who actually held power along the Nile. Ancient Greece took a more practical, if still slightly mysterious, view of the fungus. Some ancient sources describe mushrooms being fed to warriors before battle, valued for the strength and stamina they were believed to provide. Considerably more mysterious was kykeon, a drink consumed during the Eleusinian Mysteries, a set of secret religious initiation rites held annually near Athens for nearly 2,000 years, from roughly the 15th century BCE all the way until the mysteries were finally suppressed alongside the rest of pagan worship in the late 4th century CE, whose exact contents were guarded so closely that revealing them was punishable by death. What could possibly be worth guarding with a death sentence for 2,000 consecutive years in a civilization otherwise happy to argue about nearly everything else in public? Some modern researchers, including the same Gordon W.H. Son we'll meet again later tonight, have argued that kykeon likely contained a psychoactive fungus growing on grain, capable of producing the kind of profound, reality-altering experience thousands of Eleusinian initiates across the centuries including figures as prominent as Plato and Cicero, described undergoing. It's a genuinely compelling theory rather than settled fact, since no surviving initiate ever broke their sworn silence to describe exactly what was in the cup. But it would mean one of the ancient world's most influential religious experiences was, in some very real sense, a fungus working quietly behind the scenes. Greek religious life held other altered states in similarly high regard, too. Worship of Dionysus, the god of wine, ecstasy, and ritual madness, involved its own wild nighttime festivals built around achieving a state of religious frenzy. And while wine itself was the primary substance associated with Dionysian ritual, some classical historians have wondered whether other plant and fungal substances occasionally found their way into that same tradition as well, part of a much broader Greek comfort with pursuing altered consciousness as a genuine, sanctioned form of religious experience, rather than something to be feared. Rome, characteristically, found a way to make fungi serve two entirely opposite purposes at once. Wealthy Romans prized certain mushrooms, particularly what's still called Caesar's mushroom today, as a genuine culinary delicacy, an expensive, celebrated centerpiece at the kind of banquet meant to impress, so prized that special silver dishes called bolteria were crafted specifically to serve them. The Roman naturalist Pliny the Elder devoted real attention to fungi in his sprawling Encyclopedia Natural History, cataloging which species were safe and prized, and warning at length about others capable of killing a careless diner outright. At the very same time, Rome's darker political tradition had already discovered that a carefully chosen mushroom could serve a considerably more permanent purpose. In 54 C, according to the ancient historians Tacitus and Suetonius, the Emperor Claudius was fed a dish laced with the deadly death cap mushroom, reportedly on the orders of his own wife, Agrippina the Younger, clearing the way for her son, the future Emperor Nero, to take the throne. It's worth noting these accounts were written decades after the fact by historians with their own political motives, and can't be treated as an eyewitness transcript. Roman emperors were genuinely aware of exactly this kind of danger, employing dedicated food tasters specifically to sample dishes before they reached the imperial table, though evidently not carefully enough in Claudius's own case, if the histories are to be believed. Still, Claudius's death by poisoned mushroom became one of antiquity's most enduring stories, and hardly the last time in this whole account that a single deadly fungus would quietly decide who got to rule. While much of the ancient West treated fungi with suspicion, ancient China took the opposite path almost from the beginning. Chinese tradition traces the earliest medicinal use of fungi back to the legendary Emperor Shen Nong, said to have ruled around 200 BCE, and famous in Chinese legend for personally tasting hundreds of different plants, poisonous and healing alike, to determine their properties for his people, reportedly discovering the powers of Lingji in exactly this way. Legend gave way to genuine agricultural practice remarkably early. Chinese farmers were deliberately cultivating wood ear mushrooms on log stacks by around 300 BCE, and had worked out how to reliably grow shiitake mushrooms by roughly 1200 CE. Centuries before cultivation of any comparable species had even begun in Europe. China wasn't simply gathering fungi from the wild the way most of the ancient world still was. It was actively farming them on purpose at real scale. The traditional shiitake growing method, still practiced by some growers today, involved felling specific hardwood logs, inoculating them with spores, and simply waiting 1 to 2 patient years for the fungus to colonize the wood fully enough to begin reliably producing mushrooms, a genuinely long-term agricultural investment, requiring the kind of sustained patience few other ancient crops ever demanded of the people growing them. Japan later refined that same patient log cultivation method into a genuine agricultural science of its own, developing techniques for inoculating hardwood logs with shiitake spawn that spread throughout East Asia, and eventually the rest of the world, a direct, unbroken technical lineage running from ancient Chinese log growers straight through to the plastic-plugged cultivation logs sold in garden centers today. No fungus earned deeper reverence in China than Lingji, known in the West as Raisi, a glossy, reddish-brown mushroom that Taoist tradition and generations of Chinese emperors alike came to regard as the literal mushroom of immortality. Far more than a simple folk remedy, Lingji held genuine standing as an essential medicine within traditional Chinese practice, prized for centuries as a treatment believed capable of extending life itself, and searched for by imperial expeditions determined to secure it for the throne. That same reverence carried directly into Taoist alchemical practice, where physicians and mystics alike pursued a broader, lifelong search for substances believed capable of extending the human lifespan indefinitely, sometimes with genuinely dangerous results when the substance in question turned out to be toxic rather than merely rare. Lingji stood out within that same tradition specifically because it was safe, a genuinely non-toxic tonic, rather than one more risky alchemical experiment, prized precisely because Taoist physicians could recommend it to an emperor without also risking his life in the process. Chinese emperors seeking immortality weren't always so fortunate with their other alchemical pursuits. Historical records describing several rulers who reportedly sickened or died from mercury-based elixirs prepared by court alchemists chasing the very same goal, a genuinely dangerous historical backdrop that only made Lingji's quiet, gentle safety look considerably more valuable by comparison. That same reverence has aged remarkably well commercially. Rise He supplements and extracts now represent a genuine multi-billion-dollar slice of the modern global wellness industry, an emperor's ancient obsession with immortality, quietly repackaged today into capsules and powders, sold in ordinary pharmacies and health food stores worldwide. Further west, in the Persian world, fungi found one of history's most methodical early students. In the 11th century, the great Persian polymath Avicenna, known in his own language as Ibn Sina, devoted careful attention to fungi within his monumental medical text, the Canon of Medicine, sorting known species into clear categories, those genuinely healing, those outright deadly, and those simply better left alone entirely. Persian apothecaries, working from exactly this kind of careful classification, put non-toxic species to practical use treating ulcers and inflammation. Real, functioning medicine, grounded in centuries of accumulated, deliberately organized observation. Avicenna's Canon of Medicine itself went on to become required reading in European medical schools for several centuries afterward, meaning his careful, deliberately organized fungal categories quietly shaped Western medical training long after his own death. Whether the students reading him ever realized exactly where that knowledge had first come from. The Canon of Medicine itself ran to roughly 1 million words across 5 substantial volumes, an encyclopedic undertaking translated into Latin by the 12th century scholar Gerard, of Kramohna and formally adopted as standard medical curriculum at universities across Europe, remaining in active use in some institutions for nearly 600 years afterward. A genuinely remarkable publishing lifespan for any single medical text in human history. Persian mysticism found its own, considerably more poetic use for the same humble organism. Sufi poets wrote of fungi as metaphors for divine revelation, a hidden, sudden flowering of insight breaking through ordinary, unremarkable ground, and some historians believe certain psychoactive varieties may have found their way into the ecstatic chanting and whirling ceremonies known as zikr, used, quite literally, to help open the door to the kind of transcendent religious experience Sufi practice was built around pursuing. The great 13th century Persian poet Rumi, whose verses remain among the most widely read poetry in the world today, filled his own writing with agricultural and botanical imagery of exactly this kind. Seeds cracking open in darkness before anything visible ever breaks the surface. A metaphor for spiritual awakening that, whether or not fungi specifically inspired any particular verse, captures something genuinely close to how a mushroom itself actually grows, patient and invisible until the very last moment. None of this regional knowledge stayed neatly contained within its own borders for long. The Silk Road, the vast overland trade network linking China to the Persian world, and eventually to Europe, functioned as humanity's first genuinely global fungal supply chain, carrying prized medicinal species like lingji across thousands of miles of desert and mountain, slowly blending Eastern herbal tradition with Western curiosity, one cautious caravan at a time. Great trading cities strung along that same route, Chang'an in China, Samarkand in Central Asia, and eventually Baghdad further west, each grew into genuine hubs where a physician trained in one medical tradition could encounter, and sometimes adopt, an entirely different one, fungal knowledge included, carried in alongside the silk, spices, and paper. The route is usually remembered for instead. Far to the north, among Siberian peoples such as the Koryak, fungi demanded a genuinely inventive solution to a genuinely dangerous problem. The bright red and white fly agaric mushroom carried real psychoactive power and real toxicity alongside it, and local shamans first noticed something worth paying close attention to. The reindeer that grazed nearby ate these same mushrooms constantly, stumbling around afterward in what looked unmistakably like blissful intoxication, and yet never seemed to die from it. The shaman's solution was as practical as it was unusual. A reindeer's kidneys, it turned out, filtered the mushroom's genuinely dangerous toxins out of its body, while leaving the psychoactive compounds largely intact, meaning the animal's urine carried nearly all of the mushroom's trance-inducing power, with almost none of its risk. Modern chemistry has since confirmed exactly why that filtering trick worked. The fly agaric's psychoactive effects come primarily from a compound called muscimol, alongside a related, more toxic compound called ibotenic acid. And mammalian kidneys happen to filter the two compounds unevenly, passing a meaningful share of the gentler muscimol through into the urine, while retaining more of the harsher ibotenic acid in the body. Precisely the biological quirk Siberian shamans had worked out for themselves centuries before anyone had a name for either molecule. By drinking that filtered urine, rather than eating the raw mushroom directly, Siberian shamans found a considerably safer path into the same altered state, entering ritual trances to commune with the spirit world through a solution their own careful observation of the local reindeer herd had quietly handed them. Some folklorists have pointed out an almost eerie modern echo of that same red and white mushroom in a considerably more familiar winter figure. Fly agaric mushrooms grow abundantly beneath evergreen trees. Shamans practicing this same tradition traveled by reindeer sled and reportedly delivered their gathered mushrooms by entering homes through the smoke hole in the roof. And the mushroom's own coloring is precisely red with white spots. It's an intriguing, genuinely debated theory rather than settled folklore history, but more than a few researchers have wondered aloud whether Siberian shamanic tradition quietly seeded a few small details into the modern legend of Santa Claus. That same unmistakable red cap dotted with white has become one of the most instantly recognizable images in modern popular culture, entirely on its own merits. 2. Inspiring the power-granting mushrooms of the Super Mario video game franchise and echoing through the strange, size-altering fungus Alice encounters in Lewis Carroll's Alice in Wonderland. The same ancient, faintly dangerous fairy tale mushroom quietly resurfacing again and again. However far removed from any actual Siberian tundra, that same unmistakable red and white fly agaric has quietly followed European trees to entirely unfamiliar corners of the globe in a considerably more literal way than any Christmas legend ever managed. Because fly agaric depends on a mycorrhizal partnership, specifically with pine, birch, and related trees. Its spores traveled wherever nurseries shipped those same tree species for forestry plantations, and the fungus is now firmly established across parts of Australia, New Zealand, and South Africa, none of which ever had it natively before European settlement brought the trees it depends on. Local ecologists now watch it with real concern, since it can outcompete native fungi for the same tree root partnerships. One more small, unplanned consequence of moving forests halfway around the world without necessarily accounting for everything traveling along quietly underground with them. However far your own thoughts have wandered by now, that's completely fine. Let your shoulders settle a little heavier into whatever's holding you up, and let your breathing keep finding its own slow, unhurried rhythm underneath everything else we're covering tonight. As this same knowledge drifted west into medieval Europe, something changed, and it's worth asking why. Why would the very organism ancient China had spent centuries cultivating as a path to immortality become, in a country just a little further west, an object of genuine, sustained terror? Western Europe descended into a deep and lasting unease around fungi, a condition historians and mycologists now call mycophobia, associating mushrooms with witches, demonic forces, and the eerie circles known as fairy rings. Eastern Europe, Russia, and much of Asia followed the opposite path entirely, remaining thoroughly mycophilic, weaving mushrooms warmly into folklore, festivals, and the ordinary dinner table without any of that same dread. Russians even gave the pastime of foraging its own gentle, affectionate name, Tikhaya Akhoda, the quiet hunt, a beloved autumn tradition still practiced today by families who think nothing of spending an entire weekend wandering the forest with woven baskets, doing exactly what would have terrified their Western European contemporaries just a few hundred miles further west. Those fairy rings, the same eerie circles medieval villagers blamed on dancing witches and mischievous spirits, turned out to have a considerably gentler explanation once modern mycology finally examined them closely. A ring of mushrooms appearing overnight in a field isn't the work of anyone dancing at all. It's simply the visible fruiting edge of a single, continuous mycelial network. spreading slowly and evenly outward underground in every direction from wherever it first took root, pushing mushrooms up along its ever-widening perimeter. Year after year, long after any dancing feet were ever involved, Northern European folklore piled plenty of other fears onto the same humble organism. Toxic mushrooms were widely dismissed as toadstools, literally toad seeds, believed to be poisonous simply by association with the toad thought to sit upon them. And some traditions went further still, describing certain mushrooms outright as the devil's own spit, spat onto the ground wherever evil had recently passed. None of it had anything to do with actual toxicity, which had far more to do with which specific compounds a given species happened to produce, than with any toad or any devil ever coming near it. A small, wobbling yellow-orange jelly fungus called Trehemiella mesentiarica picked up its own specific piece of folklore across England and parts of Northern Europe, earning the common name witch's butter. Finding it growing on your garden gate or fence post was widely taken as a sign that a witch had cursed the household, and the accepted remedy was every bit as specific as the omen itself. Piercing the fungus with pins or burning it outright was believed to break the curse and cause the responsible witch real pain in the process. The same small fungus still grows on dead branches in gardens and hedgerows today, entirely harmless, its old reputation having long since faded into little more than a curious footnote for anyone who happens to notice it. Certain fungi in the genus Tophrena cause a separate, equally eerie-looking deformity that fed its own strand of Northern European folklore. Infected branches sprout a dense, unnaturally tangled cluster of thin twigs, all growing from a single point, a deformity called witch's broom, and medieval villagers who had no concept of plant pathology understandably assumed something considerably more sinister than a fungus was responsible. A literal broom left behind by a witch flying past overhead. The real cause turned out to be far less dramatic than the folklore, simply a fungal infection disrupting a tree's normal hormone signaling and causing dormant buds to sprout all at once in a tight, chaotic cluster, though the resulting shape is striking enough that it's easy to understand why frightened villagers reached for a witch as the simplest explanation. One genuinely strange piece of fungal biology likely fed directly into this same folklore. 2. Certain species of fungus growing on rotting would produce their own faint, greenish light through a natural chemical process called bioluminescence, an eerie glow country folklore across Europe and North America came to call foxfire. Sometimes blamed for the mysterious light's travelers, occasionally reported wandering deep in the woods at night. Modern science has since confirmed the glow is entirely real, produced by the same basic light-generating chemistry found in fireflies, just running quietly, unnoticed, in rotting logs most people would otherwise walk straight past in daylight without a second glance. That same eerie foxfire glow eventually found a genuinely practical modern use, one considerably removed from ghost stories. Miners and early loggers reportedly carried glowing foxfire wood into dark tunnels and camps as a faint, natural light source. And soldiers in the First World War are said to have used small pieces of it to read maps and mark trail routes at night, since its dim glow gave off no flame and no telltale flicker an enemy sniper might spot from a distance. A folklore-born curiosity, feared for centuries as a sign of something supernatural, turned out to be quietly useful exactly when ordinary light would have been too dangerous to risk. Even science itself got an important fungal relationship badly wrong for a while. In 1869, the botanist Simon Schwendener proposed what became known as the dual hypothesis of lichens. Those crusty, colorful growths found clinging to rocks and tree bark worldwide, arguing that the fungus half of a lichen was essentially an enslaving parasite, forcing a captured algae partner to produce sugar entirely against its own interest. Modern science has since corrected that framing considerably. The real relationship inside a lichen is a genuinely equitable, mutually beneficial symbiosis. Fungus and algae both contributing something the other genuinely needs, not a captor and its prisoner at all. The very same patient rock-breaking partnership we met right at the beginning of tonight's story, quietly at work billions of years before Schwendener ever looked at one through a magnifying glass and misread what he was seeing. Not every piece of medieval mushroom fear was pure superstition, though, and one genuinely dangerous fungus deserved every bit of the dread it eventually earned. Ergot, a parasitic fungus that infects rye and other grains, produced mass poisonings across medieval Europe severe enough to earn their own grim popular name, Saint Anthony's fire, inflicting vivid hallucinations, convulsions, and a horrifying, burning gangrene in the extremities on entire villages that had unknowingly eaten contaminated bread. Monastic hospitals dedicated specifically to treating ergotism victims sprang up across France by the 11th century, run by an order that took its own name directly from the affliction it existed to treat. The Hospital Brothers of St. Anthony. That same fungus has been proposed, considerably more speculatively, as a possible explanation for one of colonial America's most infamous episodes. Between February of 1692 and May of 1693, the small Massachusetts village of Salem descended into a genuine panic. More than 200 people formally accused, and 19 ultimately executed, most of them women, on charges of witchcraft that began with a handful of young girls suffering strange, unexplained fits. Some historians have suggested that ergot contamination in the local rye harvest may help explain those same strange fits, hallucinations, and mass accusations behind the Salem witch trials. It remains a genuinely contested theory rather than a settled explanation. One among several competing accounts historians still debate, but it's a striking possibility nonetheless, that a hidden fungus working quietly through a community's daily bread may have helped set an entire town's fear and paranoia in motion. Salem was never an isolated case in any event. The broader European witch panics of the and 1600s sent tens of thousands of people, overwhelmingly women, to their deaths, and historians have long debated how much of that same widespread hysteria might trace back to fungal contamination in the grain supply across an entire continent, rather than to any single, isolated harvest in any single town. The Bamberg witch trials, carried out in a small German prince-bishopric between 1626 and 1631, dwarfed Salem by any measure. An estimated 1,000 people executed across just a handful of years. A genuinely staggering death toll from a single regional panic, and one more entry in the same long, grim European pattern. Some researchers still connect back to ordinary bread, quietly contaminated with the very same fungus. Not everyone in medieval Europe gave in to the fear. Even so, monks quietly cultivated mushrooms in cool monastery cellars, growing them for food and for medicine alike, sheltered behind the church's own walls. Beyond those walls local folk healers and midwives carried on using fungi's genuine curative properties in their own everyday practice, fully aware that the very knowledge keeping their neighbors alive could just as easily get them accused of witchcraft themselves, should the wrong person ever take notice. If your own mind has started drifting a little further from the thread of any of this, that's exactly as it should be by now. Let your breathing stay slow and unforced, your whole body a little heavier against whatever's holding it, while the story keeps unfolding quietly on its own, needing nothing further from you at all. The Swiss physician Paracelsus, working in the early 1500s and already famous for his blunt rejection of much of medieval medical tradition, argued for a genuinely modern-sounding principle that applied directly to fungi, that the dose alone determines whether a given substance heals or kills, not any inherent good or evil quality baked into the plant or fungus itself. It was a radical idea for its era, quietly undercutting centuries of folklore that had sorted mushrooms simply into safe and cursed, and replacing it with something considerably closer to how modern toxicology still thinks about the exact same question today. Claudius's poisoned mushroom, all the way back in ancient Rome, turned out to be the opening chapter of a considerably longer story rather than an isolated one. The death cap, quietly lethal and nearly impossible to distinguish from safe, edible relatives once cooked, is widely believed to have claimed several more prominent lives across the centuries that followed. Pope Clement VII died in 1534 under circumstances historians have long suspected involved the very same mushroom, a death with real historical consequences of its own, since it was Clement's earlier refusal to annul the marriage of England's King Henry VIII that helped push Henry toward breaking with the Catholic Church entirely, reshaping English religious history within just a few years of the Pope's own death. Tsarina Natalia Narishkina, mother of the future Russian Emperor Peter the Great, is believed by some historians to have died from the same poison in 1694, and the Habsburg claimant Charles VI suffered a similarly suspicious death in 1740 after supposedly consuming a dish of sautéed mushrooms, a death that helped trigger the sprawling war of the Austrian succession, since Charles left no surviving son, and several rival European powers seized on the resulting uncertainty over his daughter, Maria Theresa's, claim to the throne. None of these later cases carry the kind of ironclad certainty modern forensics would demand. What they do share consistently across 4 separate centuries and 4 separate corners of Europe is the same quiet, patient, nearly undetectable weapon. Modern toxicology has since explained exactly why the death cap made such a uniquely effective patient poison. Its toxins, called amatoxins, don't cause any obvious symptoms for anywhere from 6 to 24 hours after being eaten, long enough that early nausea is easily mistaken for ordinary food poisoning, while the toxin quietly continues attacking the liver the entire time, undetected. By the time genuinely serious symptoms appear, the damage is often already severe, which is exactly the grim, patient quality that made this particular mushroom such a reliably effective choice for anyone in history determined to remove a rival quietly. Its danger has never been limited to deliberate poisoning, either. The death cap closely resembles several genuinely edible mushrooms prized by foragers and remains responsible for the significant majority of fatal mushroom poisonings worldwide, even today. An ordinary forager's simple, honest mistake, carrying exactly the same lethal consequence a Roman empress once relied on. The death cap's own reach has never stayed neatly confined to Europe, either, and its more recent spread is a genuinely modern ecological story rather than an ancient one. Native to Europe, Amanita phalloides is believed to have crossed the Atlantic sometime in the late 1800, likely arriving accidentally in soil packed around imported ornamental trees, and has since spread steadily along the California coastline, where it now forms the same kind of quiet underground partnership with native oak trees that it once formed only with European ones. Mycologists monitoring its advance describe it as a genuinely invasive species, one now responsible for a significant share of serious mushroom poisonings across the American West, a distinctly modern chapter for a fungus whose reputation already stretches back to a Roman emperor's dinner table. A persistent piece of survivalist folklore claims there's a reliable shortcut around all of this danger. A taste test, a color change, a reaction with silver, some simple trick capable of separating the safe mushrooms from the deadly ones in the field. Modern mycologists are unanimous that no such universal test actually exists. The only reliable method is careful, informed identification, comparing multiple physical features against a trusted guide. A considerably less romantic answer than folklore prefers, but the only one that's actually kept foragers alive. One of the most useful identification tools, a spore print, requires nothing more than resting a mushroom cap gill-side down on a sheet of paper overnight, letting its spores settle naturally into a visible pattern and reveal a telltale color: white, brown, black, or pink, depending on the species. A simple technique mycologists have relied on for generations to help distinguish otherwise strikingly similar-looking mushrooms from one another. Ergotism itself never fully disappeared into the history books the way it might be comfortable to assume. In the summer of 1951, the small French town of Pont-Saint-Esprit suffered a genuinely frightening mass poisoning after the local flour supply was accidentally contaminated with ergot, the very same fungus responsible for medieval St. Anthony's fire. Still capable, in the middle of the 20th century, of exactly the same damage it had always done. Residents experienced acute delirium and vivid hallucinations, several reportedly seeing tigers and snakes that weren't there, leading to widespread panic, a wave of psychiatric hospitalizations, and tragically, 5 deaths before the true cause was finally identified. Ergot contamination in the local bread remains the mainstream, best supported explanation for what happened, though a small number of researchers have since raised a considerably more troubling alternative, pointing to declassified American intelligence documents and speculating the town may have been an unwitting test site for a Cold War chemical experiment. That theory remains firmly unproven and disputed by most historians who have studied the case closely. But it's a reminder of just how much genuine uncertainty can still surround an event less than a lifetime old. It's a sobering, genuinely recent reminder that this particular danger was never confined to some distant, superstitious past. If a single hidden fungus could still do this much damage in the middle of the modern industrial age, what does that say about how thin the line has always been between a harvest that feeds a village and one that quietly poisons it? The very same fungus responsible for centuries of St. Anthony's fire eventually earned a genuine, permanent place in the modern medicine cabinet. Once chemists learned to isolate its dangerous compounds carefully rather than encountering them by accident in contaminated bread. Ergotamine, purified from ergot, is still prescribed today to treat severe migraines, taking advantage of the same powerful blood vessel constricting effect that once caused gangrene in medieval villages, now carefully dosed and medically supervised instead. A related compound, ergometrine, remains a standard emergency treatment for controlling dangerous bleeding after childbirth, quietly saving lives in delivery rooms around the world, using precisely the chemistry that once terrorized an entire continent. Slowly, and mostly outside the reach of any of that fear, fungi were also quietly becoming a genuine agricultural industry. Sometime in the 1600, gardeners working for King Louis XIV discovered a reliable method for cultivating button mushrooms directly on beds of composted manure, transforming what had always been a purely foraged food into something a determined gardener could deliberately grow to order. In 1707, the French botanist Joseph Piton de Tournefort formalized and published that method in real scientific detail, a technique that would go on to cross the Atlantic and reach American growers by 1865. By the late 1700s, enterprising French farmers had taken that same technique somewhere genuinely unusual, moving their growing operations into the cool, dark, abandoned limestone catacombs running beneath the city of Paris, quarried out centuries earlier and left largely empty ever since. Those constant, stable underground temperatures turned out to be nearly ideal for mushroom cultivation, and the operation growing in those tunnels beneath Paris effectively gave birth to the large-scale commercial mushroom industry as the world would come to know it, so thoroughly that button mushrooms are still sometimes called champignons de Paris today, a small linguistic fossil of exactly where the modern industry actually began. That reliance on composted manure was never a random choice, either, even if the growers of the period couldn't have fully explained why it worked so well. Composting breaks organic material down through its own natural heat and fermentation, producing a nutrient-dense growing medium already partly broken down by the same kind of microbial activity a mushroom's own mycelium thrives on, giving a young fungal network a considerably easier foothold than raw, untreated soil ever could. What does it actually take to turn a food humans had only ever gathered by luck into something a farmer could reliably promise a buyer? Season after season, year after year, the industry's next real leap forward came from the laboratory rather than the field. Researchers, including Konstantin Matrichat and the American mycologist Ferguson, working across the late 19th and early 20th centuries, finally worked out how to reliably propagate the common white button mushroom, Agaricus bisporus, directly from spores under controlled conditions, a genuine breakthrough that let growers scale up production with a level of consistency wild foraging or manure bed cultivation alone had never been able to offer. No single fungal discovery in this entire story changed more human lives than the one that happened almost entirely by accident. In 1928, the Scottish bacteriologist Alexander Fleming returned to his London laboratory after a holiday to find one of his bacterial culture dishes contaminated by a stray mold, and noticed something remarkable: a clear, bacteria-free ring surrounding the mold itself, as though the fungus were actively fighting off the bacteria nearby. That mold was penicillin, and Fleming had just stumbled onto the discovery that would define an entire era of medicine, though the wider medical world took a genuinely surprising amount of time to notice. Fleming published his findings in 1929, and the paper drew remarkably little attention, largely ignored by the broader scientific community for close to a decade, a discovery capable of saving millions of lives, sitting in plain sight, in print, for years before anyone thought to properly follow up on it. Fleming himself, remarkably, never managed to turn his discovery into an actual usable medicine, since purifying and stabilizing the compound proved to be a genuinely difficult chemical problem he lacked the resources to solve. It would take a separate team, the Australian pathologist Howard Florey and the German-born biochemist Ernst Chain, working together in Oxford more than a decade later, to finally work out how to purify penicillin reliably and prove it could safely treat infection in a living patient, transforming Fleming's accidental observation into the actual medicine that would go on to save so many lives. All three men shared the 1945 Nobel Prize in Physiology or Medicine for the achievement, a rare instance of a Nobel Committee formally recognizing that an accidental discovery and the years of unglamorous purification work that followed it deserved equal shared credit. What penicillin actually does, once inside a body, is quietly sabotage a bacterium's ability to build its own protective outer wall, a structure the bacterium absolutely needs to survive. Without that wall, the bacterium essentially bursts under its own internal pressure, unable to hold itself together, while human cells, which never relied on that same kind of wall in the first place, remain completely unaffected, a precise, almost surgical kind of chemical warfare. The penicillin mold had already been quietly waging against its bacterial rivals for millions of years before Fleming ever noticed it happening in a petri dish. Penicillin's success sent researchers around the world hunting for other soil and water fungi capable of the same trick. And one of the most important came from a genuinely unglamorous source. In 1945, the Italian scientist Giuseppe Brozzu, investigating why seawater near a Sardinian sewage outflow seemed to stay unusually free of dangerous bacteria, isolated a fungus called Cephalosporium acraemohneum directly from the contaminated water, and found it produced its own powerful antibacterial compound. That discovery eventually led to an entire new family of antibiotics, the cephalosporins, still widely prescribed today for infections resistant to penicillin itself, an entire branch of modern medicine tracing its origin back to a fungus, quietly doing its work in a stretch of ordinary coastal sewage outflow nobody else had thought to examine closely. Fleming's own genus of mold has spent centuries doing far gentler, far tastier work in kitchens across the world, long before anyone thought to ask it for medicine. Different cultivated strains of penicillium give blue cheese its distinctive marbled veins, and Roquefort its sharp bite, while a closely related mold forms the soft, edible white rind on a proper wheel of brie or camembert. An entire category of beloved cheese, quietly built on deliberately, carefully cultivated mold. The exact same basic genus responsible for penicillin working, this time purely in service of flavor rather than survival. Beer and wine owe their existence to a fungus too. The single-celled yeast Saccharomyces cerevisiae, quietly converting sugar into alcohol and carbon dioxide in fermentation vessels for at least 7,000 years. A humble microscopic fungus with a fair claim to being the single most economically consequential organism fungi have ever produced. Archaeologists working at Abydos, one of ancient Egypt's oldest religious centers, uncovered direct physical proof of exactly how seriously early Egyptians took that same fermenting yeast. The site contains the remains of a massive brewing operation dating back roughly 5,000 years, built around rows of large fired clay vats capable of producing an estimated well over 5,000 gallons of beer at a single time. Among the oldest large-scale breweries ever identified anywhere on Earth, beer wasn't a casual indulgence in early Egyptian society either, but a genuine dietary staple consumed by workers and nobility alike. And current evidence suggests this particular brewery existed specifically to supply beer for royal ceremonies and rituals. An entire industrial-scale operation built around the same single-celled fungus, quietly still fermenting bread and wine everywhere else in this same story. Fungi shape considerably more of the world's food than most people ever realize. Tempeh, the firm, nutty fermented soybean staple of Indonesian cooking, gets its distinctive texture from a fungus called Rhizopus, whose fine white mycelium binds loose soybeans together into a single solid block, while a separate mold, Aspergillus oryzae, does the essential fermenting work behind soy sauce, miso, and sake alike, an entire category of foundational East Asian flavor resting on fungal fermentation most diners never think to credit. That same mold, known in Japan as kohg, is considered important enough to national identity that the Brewing Society of Japan formally designated it the country's official national fungus in 2006, an almost ceremonial honor for the humble microorganism quietly responsible for sake, miso, and soy sauce alike. That same basic trick, fermenting a fungus at industrial scale, has recently been put to an entirely new purpose. Mycoprotein, sold commercially since the 1980 under brand names like Quorn, is produced by fermenting a specific fungus, Fusarium veneanatum, in large steel vessels, growing its fibrous mycelium into a protein-rich meat substitute now sold in supermarkets across dozens of countries, a genuinely modern industrial process built on precisely the same fungal fermentation humanity has quietly relied on in one form or another for thousands of years already. It would take more than a decade of further research before penicillin reached its full potential. But by the Second World War, mass production of the drug was finally underway, saving an estimated 200 million lives in the decades since, and fundamentally transforming what modern medicine was even capable of. A wound infection that had reliably killed soldiers for the entirety of human history suddenly, quietly, stopped being an automatic death sentence, all because of a humble mold that happened to drift in through an open laboratory window. Scaling penicillin up to genuine wartime volume still needed one more stroke of ordinary luck. American researchers at a government laboratory in Peoria, Illinois, spent the early 1940s searching the world for a more productive strain of penicillin than Fleming's own original mold, sending requests to labs and markets everywhere for moldy fruit and soil samples. It was a laboratory assistant working locally, remembered afterward by colleagues by the nickname Moldy Mary, who brought in a mold-covered cantaloupe from an ordinary Peoria grocery stand that turned out to carry a strain hundreds of times more productive than anything researchers had tested before. Nearly every commercial penicillin produced anywhere in the world since has descended from that one unassuming cantaloupe, an entire global pharmaceutical industry, tracing its lineage back to a single piece of spoiled fruit bought on an ordinary American street corner. Penicillin turned out to be far from the last major medicine fungi would quietly hand to modern doctors. Cyclosporine, a compound isolated from a soil fungus in the 1970s, gave surgeons the ability to suppress a transplant recipient's immune system just enough to stop their body from rejecting a donated organ, transforming organ transplantation from a desperate long shot into a genuinely reliable, life-saving procedure. Statins, among the most widely prescribed cholesterol medications in the world today, trace their own origin back to compounds first identified in red yeast rice, a fungus-fermented food used in Chinese medicine for centuries before Western pharmacology ever isolated its active ingredient. More recent research has turned attention to lion's mane, a shaggy, white, distinctly unmushroom-looking fungus long used in traditional Chinese medicine. After laboratory studies found it appears to stimulate the production of nerve growth factor, a protein involved in maintaining and repairing the brain's own nerve cells. Human clinical research remains genuinely preliminary and far from conclusive, but early findings exploring lion's mane's potential to support memory and cognitive function have made it one of the more actively studied medicinal mushrooms in modern laboratories today. A fungus traditional healers were already recommending for mental clarity centuries before anyone had a word for nerve growth factor at all. What is it about a mushroom, specifically, that so many entirely disconnected civilizations kept reaching for whenever they imagined cheating death? It's worth pausing on how consistently that same specific hope keeps resurfacing across this entire story in wildly different centuries and wildly different languages. Egyptian pharaohs called their hoarded fungus a plant of immortality. Chinese emperors called lingji the mushroom of immortality. Persian Sufis saw fungi as a doorway to divine revelation. And W.H. Sun himself would later go looking for that exact same theme buried inside ancient Vedic hymns. Whatever fungi actually are, biologically, humanity has apparently never quite been able to shake the sense that this particular kingdom of life sits closer to something eternal than anything else growing beside it. Let your shoulders drop just a little further now, wherever you happen to be resting. There's still more of this story ahead, but none of it needs holding onto. Just let it drift past, gently, while your own breathing keeps settling deeper into rest. Fungi's most consequential modern chapter, though, began with an argument between newlyweds. The American banker R. Gordon W.H. Sun and his Russian-born wife, Valentina Pavlovna, discovered on their honeymoon that they held completely opposite instincts about mushrooms. Her deep, culturally inherited love of foraging running headlong into his instinctive American unease around anything growing wild in a forest. Trying to make sense of that divide, the couple eventually coined two lasting terms for it themselves: mycophilia for cultures that embraced fungi, and mycophobia for cultures like the one W.H. Sun had grown up in, that instinctively feared them. W.H. Sun's own instinctive unease traced back further than his own upbringing. In fact, echoing the same wary, mycophobic tradition, English Puritan colonists had originally carried across the Atlantic centuries earlier. A fear that quietly persisted in mainstream American culture for generations, even as it settled into a landscape whose indigenous peoples had long since worked out their own confident, detailed relationship with the very same wild fungi. W.H. Sun himself spent his working life about as far from mycology as a career could reasonably get, rising to become a vice president at the banking firm J.P. Morgan. An unlikely professional background for the man who would go on to reshape how the entire Western world thought about mushrooms. pursuing his genuine, self-taught fascination with fungi, almost entirely on evenings and weekends. Alongside a demanding career that had nothing whatsoever to do with it, that personal fascination eventually carried W.A.H. son to Wowtla de Jimenez, a small, remote Aztec village high in the mountains of Oaxaca, Mexico, in 1955. Precisely the kind of isolated, hard-to-reach location where a sacred, colonially forbidden tradition had the best chance of quietly surviving 4 centuries unnoticed. There, a respected local healer named Maria Sabina agreed to let him participate in one of the same sacred mushroom ceremonies Aztec priests had practiced centuries earlier, a tradition her own community had quietly preserved, largely unchanged, through 400 years of official suppression. Sabina called these all-night healing ceremonies Ve'alahdas, and conducted them not through silent ritual alone, but through hours of spoken and sung improvised chanting, weaving together Catholic prayer, Aztec cosmology, and her own personal visions into a continuous, deeply poetic performance meant to guide participants toward healing or answers. A genuinely sophisticated oral art form, W.A.H. son himself later admitted he'd badly underestimated on that very first night. W.A.H. son later described that night as one of the most profound experiences of his entire life, and he became the first outsider from beyond the immediate region ever known to formally document, in his own words, actually participating in one of these ceremonies rather than simply observing or writing about it secondhand. He returned to New York, convinced the wider world needed to know what he'd witnessed, a conviction that would end up reshaping both his own reputation and Maria Sabina's entire life, for better and for considerably worse. W.A.H. son wrote about that experience for Life magazine in 1957 in an article that introduced the phrase magic mushrooms to a mass Western audience for the very first time, and effectively launched psilocybin mushrooms into modern pop culture almost overnight. Working from specimens W.A.H. son brought back from that same expedition, the Swiss chemist A. Albert Hoffmann, already famous for having synthesized LSD by accident in his own laboratory more than a decade earlier, went on to isolate and formally name the 2 active compounds responsible for the experience: psilocybin and psilocin, finally giving Western science a precise chemical name for something Mesoamerican healers had understood on their own terms for well over 1,000 years. It's a small, striking coincidence worth noticing that the two most consequential psychedelic compounds of the entire 20th century both ended up being identified and named by exactly the same Swiss chemist. Hoffman's own path to that laboratory bench had actually begun with the very same fungus already covered earlier tonight. Working at the Sandoz Pharmaceutical Company in Basel in 1938, Hoffman had first synthesized lysergic acid diethylamide while investigating ergot's chemistry for possible circulatory medicines, then set the compound aside as apparently unremarkable. 5 years later, in April of 1943, he accidentally absorbed a small amount through his skin while resynthesizing it and experienced the first known LSD trip in human history, an event unsettling enough that he deliberately dosed himself again 3 days later to confirm what had happened, then rode his bicycle home through the streets of Basel in the middle of a full-blown psychedelic experience, a journey still celebrated informally by enthusiasts every April 19th as Bicycle Day. It's a striking detail that the same Swiss chemist who years later gave psilocybin its name had already, entirely by accident, discovered the 20th century's most famous psychedelic compound through a completely different fungus altogether. By 1979, a small group of scholars, uncomfortable with how casually the word hallucinogen dismissed these substances' genuine religious significance across so many of the cultures we've already met tonight, coined an entirely new term specifically for their sacred, ceremonial use, entheogen, roughly translating to generating the divine within. It's the word many modern researchers and indigenous advocates still prefer today, a small linguistic correction aimed at restoring some of the reverence W.H. Sun's own casual magic mushroom headline had, however unintentionally, stripped away. W.H. Sun himself spent much of the rest of his life chasing one final, considerably more ambitious fungal mystery. In a 1968 book, he proposed that soma, a mysterious sacred drink described in the ancient Vedic hymns of India, praised in verse for granting visions and communion with the gods, but never once clearly identified by name in the surviving texts themselves, was very likely the same fly agaric mushroom Siberian shamans had been safely consuming through filtered reindeer urine for centuries. It remains a genuinely debated theory rather than a settled identification. But if W.H. Sun was right, one single red and white mushroom would connect Vedic priests, Siberian shamans, and, by his own account, quite possibly Santa Claus, an almost absurdly long reach for one fairly ordinary-looking fungus. That fame came at a genuinely devastating cost, and the story deserves to be told honestly rather than left out. W.H. Sun's article triggered a flood of curious, often disrespectful Western visitors into Ma'ari'a Sabiina's small village, overwhelming and permanently disrupting a sacred tradition that had survived centuries of colonial suppression, specifically by staying quiet. Her own community, blaming her for inviting that disruption, turned against her. Her house was burned, and one of her sons was murdered. Ma'ari'a Sabiina, the woman whose generosity had opened this entire chapter of modern history to the West, died in poverty in 1985, having gained the world very little, and lost almost everything she actually had. In the decades since, Mexico has slowly, belatedly moved to honor her properly, recognizing Ma'ari'a Sabiina today as one of the country's most significant spiritual and cultural figures. Her recorded chants, preserved and studied by later generations of researchers. Her name, now spoken with the same reverence her own healing once carried within her own village before a magazine article ever reached it. The wider psychedelic curiosity W.H. Sun had helped unleash was itself heavily criminalized across the United States and much of the world by the 1970s, driving psilocybin research almost entirely underground for decades. Only in recent years has that research meaningfully resumed, with institutions including Johns Hopkins University conducting careful, closely monitored clinical trials exploring psilocybin's potential to treat depression, post-traumatic stress, and the profound anxiety many people face at the end of life. Johns Hopkins researchers formally opened a dedicated center for psychedelic and consciousness research in 2019, one of the first of its kind at a major American research university. And early published trials there have reported meaningful, lasting symptom relief for patients suffering from severe, treatment-resistant depression, administered under carefully controlled clinical conditions, entirely unlike anything resembling casual use. Modern protocols lean heavily on a principle first articulated by psychedelic researchers back in the 1960s, that a person's mindset and physical surroundings, commonly shortened to set and setting, shape the experience every bit as much as the substance itself, which is exactly why today's clinical sessions unfold in calm, comfortable rooms under the steady supervision of trained therapists, rather than anywhere resembling a casual, unsupervised setting. Similar dedicated research centers have since opened at Imperial College London and New York University, a genuinely international scientific community slowly, carefully rebuilding exactly the kind of rigorous research infrastructure that decades of blanket criminalization had once made almost entirely impossible to sustain. It represents a slow, cautious scientific return to territory Ma'ari'a Sabi'ina's own tradition had already been quietly, generously exploring for centuries. Early published results have been genuinely striking by the usual standards of psychiatric research. One widely cited Johns Hopkins trial found that roughly 2/3 of participants with major depressive disorder showed significant symptom relief a full month after just 2 carefully supervised sessions, with meaningful benefits still measurable in many patients a year later. Results considerably stronger and more durable than most standard antidepressant medications typically produce, though researchers are careful to stress that larger, longer studies are still needed before any of this becomes standard, widely available medical practice. That renewed scientific interest has begun shifting federal research policy as well as state law. The United States Food and Drug Administration granted psilocybin its official breakthrough therapy designation for treatment-resistant depression in 2018, a formal acknowledgement that early clinical evidence looked promising enough to justify fast-tracking further research, a genuinely significant status for a substance that had spent the previous 4 decades classified as having no accepted medical use whatsoever. State law began shifting too. In 2020, Oregon became the first American state to formally legalize supervised psilocybin therapy for adults, followed soon after by Colorado, both states carving out narrow, tightly regulated exceptions specifically for licensed, supervised therapeutic use rather than any broader decriminalization of recreational use. It's a genuinely cautious first step, nearly 50 years after the same substance was pushed entirely underground, and still a very long way from anything resembling the open, sanctioned tradition Maari'a Sabiina's own village once quietly maintained for centuries before W.H. Sun ever arrived. Other countries have arrived at their own considerably more varied answers to the same basic question. The Netherlands never explicitly legalized psilocybin mushrooms themselves, but a long-standing quirk in Dutch law left psilocybin truffles, a related underground growth stage of the same fungus, entirely unregulated, openly sold in Amsterdam shops for years as a direct, if slightly unusual, legal workaround. Brazil and Jamaica, meanwhile, have never criminalized psilocybin mushrooms in the first place, a reminder that the entire strict, decades-long prohibition W.H. Sun's own country pursued so aggressively was never actually a universal global consensus to begin with. That renewed public fascination with magic mushrooms has also carried along a fair amount of misinformation, worth gently correcting. A widespread modern assumption holds that magic mushrooms universally grow out of animal dung. But in reality, of the more than 165 known species of psilocybe, most actually grow on wood chips, in open grassland, or scattered across an ordinary forest floor. Only a small handful of species, most notably Psilocybe cubensis and Psilocybe atlantis, favor dung specifically at all. Psilocybe mushrooms carry one more distinctive, genuinely useful physical trait worth knowing about. Bruise or cut the stem of most psilocybin containing species, and the damaged flesh will slowly turn a visible blue-green within minutes, a reaction caused by psilocin oxidizing on contact with air, chemically similar to the way a sliced apple browns once exposed. Foragers and mycologists alike have long used that telltale bluing reaction as one helpful clue during identification, though experienced guides are always careful to add that bruising blue is suggestive rather than definitive on its own, since a handful of other non-psychoactive species happen to bruise a similar color for entirely unrelated chemical reasons. A second popular belief fares no better under real scrutiny. Enthusiasts frequently insist that different cultivated strains of Psilocybe cubensis, sold under colorful names like Golden Teacher or Penis Envy, produce meaningfully different kinds of experience. One supposedly calmer, another supposedly more energizing. Careful genetic and chemical analysis has found no real scientific backing for any of these claims. However creative the branding gets, chemically and genetically, a cube is still simply a cube. We're well past the halfway point of tonight's walk now, if that's useful to know at all. There's no need to track it closely. Just let your breathing stay slow and easy, your body heavier against whatever's holding it, however far off sleep still happens to be. One considerably more speculative idea deserves an honest hearing here too, precisely because it's become so widely repeated online without the caveats it actually needs. What would it actually take to explain why human intelligence, language, and art all seem to have expanded so dramatically in such a comparatively short evolutionary window? In the 1970, the researcher Trance, Mickey N.A., proposed what's since become known as the stoned ape theory. The idea that early human ancestors eating psychedelic mushrooms may have acted as a genuine catalyst for the sudden, rapid expansion of the human brain and the emergence of language, art, and complex society sometime between 50 and 70,000 years ago. It's important to say plainly that the stoned ape theory remains firmly on the fringes of accepted science, since there's remarkably little direct archaeological evidence from that period capable of actually proving it either way. What's genuinely changed in recent years isn't proof of the theory itself, but a small handful of modern findings that at least offer a plausible biological mechanism for how something like it could theoretically work. A study published in the journal Brain in January of 2024 found a direct connection between stimulation of specific serotonin receptors, the same receptors psilocybin binds to once metabolized in the body, and measurable growth and activity in the brain's motor cortex. Psilocybin itself is technically inactive when eaten, converted almost immediately by the body's own liver enzymes into psilocin, the actual compound responsible for binding to those same serotonin receptors. A small but genuinely important chemical detail that the mushroom's famous effects come from a transformation happening entirely inside the person eating it, not from the raw mushroom itself. Separately, modern brain imaging has shown that psilocybin significantly quiets what neuroscientists call the brain's default mode network, the system responsible for filtering out sensory noise. and keeping ordinary waking consciousness feeling stable and familiar. Temporarily loosening that filter, some researchers have speculated, might have given early humans brief access to unusually expanded states of awareness. States some believe could plausibly have inspired the drive to develop complex language in the first place, simply to describe what they'd experienced to one another. McKenna's original theory went further still, proposing that mushrooms may have acted as a mild aphrodisiac too, encouraging more frequent mating, while the individuals most able to make sense of these expanded states became unusually persuasive, capable leaders, passing both their genes and their command of language on to following generations. None of this amounts to proof. It amounts, at best, to a genuinely interesting, open question modern neuroscience has only just begun to take seriously. Whatever the truth of humanity's deepest evolutionary past, fungi's place in the modern global economy is considerably easier to measure. Today's mushroom industry is worth more than $70 billion worldwide, an almost unrecognizable transformation from the days of Louis XIV's palace gardeners. China alone now produces more than 70% of the entire world's supply, while Poland, somewhat less expectedly, emerged in 2014 as the single largest exporter of mushrooms on Earth. Poland's rise to the top of the export market traces back to a favorable mix of low production costs, a long-established domestic growing tradition, and its convenient geographic position at the edge of the enormous, mushroom-hungry European Union market, allowing Polish growers to ship fresh product to German and British supermarket shelves within a day or two of harvest, an advantage no distant overseas competitor could easily match. At the opposite end of the market from mass-produced button mushrooms sits the truffle, an underground fungus still gathered almost entirely the old-fashioned way, using specially trained dogs and occasionally pigs to sniff it out beneath the soil, since no one has ever managed to reliably cultivate the rarest and most prized varieties on any real commercial scale. Italian hunters increasingly favor a specific breed for the job, the curly-coated Lagatto Roman YOHLO, originally bred centuries ago as a water retriever and gradually reshaped by generations of truffle hunters into the sharpest-nosed, most reliable truffle dog in the business. Prized over pigs today mainly because a dog, unlike a genuinely hungry pig, has no particular interest in eating the valuable prize the moment it's found. A single kilogram of the finest white alba truffle can sell for thousands of dollars, a genuinely startling price for a plain-looking underground fungus, driven almost entirely by how stubbornly it resists exactly the kind of controlled cultivation that turned the button mushroom into a $70 billion global industry. That underground growth habit isn't an accident of evolution. Either truffles developed their powerfully pungent aroma specifically to attract animals willing to dig them up and eat them, trading a portion of their own body for the free transportation an animal's gut provides, carrying spores well away from the parent fungus and depositing them, already fertilized with a helpful dose of natural manure, somewhere entirely new to grow. France's own black Perigioir truffle built a comparable, centuries-long mystique of its own, celebrated by generations of French gastronomes, and eventually nicknamed the Black Diamond of French cooking. Popular legend has long credited truffles with genuine aphrodisiac powers, a claim that made its way into French folklore and dinner table conversation for centuries, repeated by figures from Napoleon-era society down to modern chefs. Though it's worth being honest that no serious modern nutritional science actually backs the claim, which appears to owe more to the truffle's rarity, aroma, and sheer expense than to any real chemical effect. What's considerably better documented is simple economics. A bad truffle harvest can send Perigioir market prices soaring within days. A fragile, weather-dependent industry that still, after all this time, resists the kind of reliable, large-scale cultivation that transformed the ordinary button mushroom centuries ago. However heavy your eyelids have gotten by now, that's exactly where they're meant to be. Let your breathing stay slow, your body settling further with every quiet exhale, while the rest of tonight's story keeps unfolding gently around you. Japan holds a similarly fierce devotion to Matsutihk, a fragrant wild mushroom traditionally gifted between families each autumn as a genuine mark of respect, prized highly enough that Japan now imports the majority of its own Matsutihk supply from Korea, China, and even the forests of the American Pacific Northwest. To meet domestic demand, its own native forests can no longer satisfy alone, with the very finest specimens still capable of selling for hundreds of dollars apiece during the short autumn season. Moral hunters across the American Midwest carry on a comparable seasonal devotion of their own. Entire small towns hosting annual spring festivals built around the brief, unpredictable weeks when the prized, honeycombed fungus finally pushes up through the forest floor. Australia's own arid interior turned out to hold its own quiet fungal tradition, considerably less famous than a European truffle, but gathered with the very same patient skill. Native desert fungi, sometimes called native truffles, grow just beneath the surface of dry red sand across parts of the outback, and have long been recognized and harvested by Aboriginal Australian communities as a genuine bush food, part of the same deep, practical knowledge of the land passed down through countless generations. Small burrowing marsupials like the bilby rely on the very same buried fungi as a food source, unknowingly helping spread their spores across the desert in exactly the same way a French truffle depends on being dug up and eaten to reproduce. One more version of that same ancient underground bargain, playing out on the opposite side of the planet from Perigioar. Part of that devotion comes down to genuine chemistry rather than sentiment alone. Mushrooms are naturally rich in glutamates, the same compound responsible for umami, the deep, savory fifth taste alongside sweet, sour, salty, and bitter, which is exactly why dried shiitake shows up so often in Japanese dashi broth, and why a handful of dried porcini can quietly deepen an entire pot of soup fungi, doing on the stovetop precisely what they've always done everywhere else, patiently making something more out of what's already there. Fungi have quietly shaped the craft world too, in a way most furniture buyers never think to ask about. When certain fungi begin colonizing a fallen or standing dead log, they produce dark, winding boundary lines called zone lines, marking the invisible borders where competing fungal colonies meet and chemically fend each other off. Woodworkers prize the resulting pattern, known as spalted wood, dramatic black streaks running through pale timber, cutting the partially decayed log at exactly the right moment before the same fungus goes on to weaken the wood too far to use, turning what started as ordinary decomposition into some of the most visually striking material available to any furniture maker or wood turner. The prized true moral has a considerably more dangerous look-alike worth knowing about too, since the two are mistaken for each other often enough to matter. False morals, wrinkled, reddish-brown fungi that look distinctly brain-like rather than properly honeycombed, contain a toxin called gyromitrin, which the human body converts into monomethylhydrazine, a compound genuinely close enough in structure to rocket fuel that it has, at various points, actually been used as one. Some cultures do eat false morels after careful parboiling, which drives off much of the toxin, but mycologists generally discourage the practice since the compound builds up with repeated exposure and has caused documented poisonings and deaths. One more reminder that a fungus prized on one table can be a genuine hazard just a few careless steps away. Fungi have found their way into an entirely different corner of the modern market too, well beyond the dinner plate. A growing wellness trend has brought ricey, lion's mane, and chaga mushrooms into everyday coffee blends and supplement powders, sold as gentle, so-called adaptogens meant to support focus and calm. The scientific evidence behind many of these specific wellness claims remains considerably thinner than the marketing around them suggests, though the underlying instinct, reaching for a mushroom in pursuit of better health, is, as tonight's whole story has already made clear, one of the oldest habits our species has. Even now, fungi are still quietly capable of surprising the scientists studying them. Forest researchers had actually noticed the pattern years earlier. A strange, unexplained band of dying and dead trees sweeping across large sections of the forest, but assumed for a long time they were simply looking at the ordinary work of several separate, unrelated fungal infections spread across the landscape. In 1998, researchers investigating Oregon's Malheur National Forest finally ran DNA testing on samples collected from opposite ends of that dying zone, fully expecting to confirm several distinct organisms, and found something nobody expected. A single Armillaria fungus, commonly called the honey mushroom, had spread its underground network across more than 2,300 acres of forest, and genetic testing confirmed every part of that vast network was one single, genetically identical organism, estimated to be at least 2,400 years old. That single organism, still quietly growing beneath the forest floor today, is now considered the largest individual living thing ever discovered on Earth by area, dwarfing even the largest blue whale by an almost incomprehensible margin. An entire ecosystem's worth of mushroom sitting patiently underground, mostly invisible, doing nothing more dramatic than continuing to grow, one more inch outward, one more year at a time. That same underground pattern, one organism quietly connecting far more of a forest than anyone standing above ground could ever guess, turns out to be the ordinary rule rather than a rare exception. Researchers generally separate these partnerships into two broad types: ectomycorrhizal fungi, which wrap themselves entirely around a root's outer surface, especially common among pines and oaks, and arbuscular fungi, which push their own threads directly inside a root's individual cells, the more ancient and considerably more widespread arrangement found in the roots of the great majority of plant species alive today. Either way, the underlying deal is the same: sugar traded for water and minerals, an ancient partnership quietly running underneath nearly every forest on the planet. Orchids depend on that same underground partnership in a considerably more extreme way than most other plants ever do. An orchid seed is astonishingly tiny, little more than a speck of dust, with almost no stored food energy of its own, meaning it cannot sprout at all under natural conditions without immediately partnering with a compatible mycorrhizal fungus to supply the nutrients a normal seed would otherwise carry inside itself. Without the right fungus present in the soil, a scattered orchid seed simply never germinates. However fertile the ground around it might otherwise look, one of the plant kingdom's most complete dependencies on this same quiet underground kingdom we've been following all night. Vast underground mycorrhizal networks link the roots of countless trees across an entire forest, allowing them to share nutrients, water, and even chemical warning signals about approaching insect attacks with one another. A genuinely cooperative, forest-wide communication system some researchers have taken to calling the wood wide web. The mycologist Paul Stamets has spent much of his career championing exactly this idea that a forest isn't really a collection of separate, competing trees at all, but something considerably closer to a single, patiently cooperating community, held together underground by fungus. Climate researchers have recently taken a real interest in that same underground network for an entirely practical reason. Mycorrhizal fungi help lock a meaningful share of a forest's absorbed carbon directly into the soil itself, rather than letting it cycle back into the atmosphere as quickly as it otherwise might. Meaning, a healthy underground fungal network may be quietly doing real, measurable work, slowing climate change. One more task this same ancient kingdom has apparently been handling in the background all along, long before anyone thought to ask it for help with that one either. It's worth being honest, too, that the more dramatic popular version of the wood wide web, trees deliberately warning and even nurturing their favorite offspring through some kind of underground conversation, has drawn real pushback from other forest scientists in recent years, who argue the evidence for genuinely intentional message-like communication remains considerably thinner than some popular books and documentaries have suggested. The underlying nutrient-sharing network itself is real and well documented. Exactly how much of it deserves to be called communication, in any sense resembling how you and I might use that word, is still a genuinely open, actively argued scientific question. That same underground partnership has become a genuine, practical tool for land managers trying to undo damage rather than simply study it. Degraded farmland, strip-mined hillsides, and land cleared by wildfire often lose much of their native mycorrhizal fungal population along with their topsoil, leaving young replanted trees and crops struggling to take root in soil that can no longer properly feed them. Restoration, foresters, and commercial growers alike now routinely add mycorrhizal inoculant, essentially concentrated fungal spores packaged as a powder or gel, directly into the planting hole alongside a new sapling or seed, deliberately reintroducing the same underground partnership that would otherwise take years to reestablish naturally on its own, quietly speeding up exactly the kind of soil-building labor fungi have been doing patiently and for free since long before there was any soil worth building at all. Engineers and designers have recently started asking a genuinely new question about that same underground material, wondering what else mycelium, the fine root-like fungal tissue running beneath nearly every forest floor, might actually be good for. Grown quickly under controlled conditions and shaped inside simple molds, mycelium can already be turned into fully biodegradable packaging material, a genuine vegan leather alternative, and early experimental building materials capable of quietly repairing their own small cracks over time, all without a single drop of petroleum involved anywhere in the process. Companies, including Ecoviewitiv and MyCoWorks, have already moved this technology well past the experimental stage, growing mycelium into genuine commercial packaging and leather alternative products now used by major furniture and fashion brands. a real functioning industry, quietly built on the same basic fungal tissue that once, unnoticed, spent 1 billion years turning bare rock into fertile soil. Akoviawitiv itself began, fittingly enough, as a student engineering project. 2 college classmates searching for a genuinely biodegradable alternative to polystyrene foam packaging before their small dorm room experiment grew into a full commercial operation, supplying materials to major manufacturers. Major fashion and luxury houses have taken real notice, several launching limited handbag and footwear lines built from mycelium leather in recent years, betting that a material grown quietly in a warehouse over the course of a couple of weeks might eventually rival cattle hide as an industry standard. Without a single animal, and without the years a cow itself would otherwise need to grow. How do you build a house on a planet with no forests, no quarries, and no way to ship in lumber across tens of millions of miles of empty space? NASA itself has taken a genuine, serious interest in exactly this material, researching whether mycelium could be grown into lightweight, self-assembling structures capable of forming actual habitats for future human settlements on the Moon or Mars, an idea that sounds almost like science fiction. Until you remember this is the very same organism that quietly built the first fertile soil this planet ever had, more than 1 billion years before anyone thought to ask it for help a second time. The specific project, called myco-architecture, by the NASA researchers pursuing it, envisions astronauts carrying nothing more than a lightweight, dormant fungal starter kit on the journey out, then growing an actual functioning habitat directly on site once they arrive, using local Martian regolith and whatever biological material could be spared, rather than hauling every single wall and support beam across tens of millions of miles of open space at enormous expense. It's the same basic trick fungi have always specialized in, turning almost nothing into something usable, just aimed now at an entirely new planet. Wherever your own thoughts have drifted to by now, there's no need to pull them back. Let your body keep sinking further into rest, your breathing slow and steady, carrying you gently the rest of the way through what's left of tonight. Fungi's own record isn't purely one of quiet generosity either, and it's worth being honest about that before turning to the cleanup work ahead. A fungal blight accidentally introduced to North America in the early 1900s wiped out an estimated 3 billion American chestnut trees within just a few decades, functionally erasing a species that had once made up a full quarter of some eastern forests. One of the most devastating ecological losses in modern American history, caused not by any human hand directly, but by a single microscopic fungus riding quietly along on imported nursery stock. Dutch elm disease, a separate fungal blight spread by bark beetles, dealt European and North American cities a comparably brutal blow throughout the 20th century, stripping tree-lined streets bare across entire regions and permanently changing the visual character of towns that had built their identity around stately, arching elm canopies for generations. A comparable threat is actively unfolding in banana plantations around the world right now, not safely tucked away in the past at all. A soil-borne fungus known as Panama disease or Fusarium wilt is steadily spreading through the Cavendish banana, the single variety responsible for the overwhelming majority of bananas sold internationally today, and has already devastated plantations across Asia, Africa, and Latin America, leaving plant scientists racing to develop a resistant replacement variety before the world's most familiar banana potentially goes the same way as its own predecessor. An earlier variety called Gros Mitchell, essentially wiped out by an earlier strain of the same fungus back in the mid-20th century. It's worth a quick, honest correction here too, for anyone who's heard the Irish potato famine described as a fungal disaster. The organism actually responsible, Phytophthora ineffiestans, is technically an oomycete, a water mold that merely resembles a fungus, closely enough to have been lumped in with them for centuries. One more reminder that even genuine experts spent a very long time sorting out exactly where the boundaries of this kingdom actually sit. A far quieter, less dramatic fungal threat causes considerably more harm worldwide than any single blight or crop disease, simply because it targets food already sitting in storage, rather than a living plant in the field. Aspergillus flavus, a common mold that can grow on improperly stored grain, corn, and peanuts, produces a group of toxic compounds called aflatoxins, among the most potent naturally occurring carcinogens known to science, linked to elevated liver cancer rates in regions of the world where humid storage conditions make contamination difficult to fully prevent. Modern food safety systems now routinely test grain shipments for aflatoxin contamination before they are ever allowed to reach a store shelf, an unglamorous but genuinely life-saving piece of everyday food safety work, built entirely around keeping one particular fungus in check. Not every fungus that infects a crop is treated purely as a disaster worth eradicating, and Mexico offers one of the clearest counterexamples in this entire story. Ustielih gomedis, a fungus that infects corn and swells its kernels into large, silvery gray galls, is treated by most American farmers today as a costly agricultural pest. In Mexico, that same infected corn, called huitlacoche, is instead harvested deliberately and prized as a genuine culinary delicacy. Its rich, earthy, faintly smoky flavor built directly into quesadillas and traditional dishes, with a lineage stretching back to Aztec cooking. One more small, fitting echo of Teonanahkot's own sacred status in the very same region. A fungus, once again, treated less like an intruder and more like a gift. Fungi's talent for quietly cleaning up messes turns out to extend considerably further than packaging and building material. A field researchers have taken to calling mycormediation. Certain species have demonstrated a genuine, measurable ability to break down plastics that would otherwise persist in landfills for centuries, and to consume the toxic components left behind by oil spills, slowly converting environmental disasters back into something closer to ordinary, harmless soil. Oyster mushrooms, in particular, have already been used in real-world pilot cleanup projects, laid across oil-contaminated soil in specially designed mats. Their mycelium visibly breaking down petroleum hydrocarbons within weeks, considerably faster than the same contaminated ground would ever have managed to recover, left entirely on its own. Perhaps most remarkably of all, researchers investigating the ruins of the Chernobyl nuclear plant discovered thriving colonies of extremophile fungi, including a species called Cladosporium sphaerospermum, growing directly on the walls of the damaged reactor itself, in radiation levels that would be swiftly lethal to nearly any other form of life on Earth. These particular fungi appear to use a pigment called melanin, the very same pigment responsible for human skin tone, to actually absorb ambient radiation and convert a portion of that raw energy directly into usable fuel for their own growth. A process researchers have named radiosynthesis, thriving in the one environment almost nothing else on the planet could ever hope to survive in. That same radiation-eating fungus has since been tested aboard the International Space Station, grown in a thin experimental layer, specifically to measure how effectively it might shield astronauts from cosmic radiation during future long-duration missions. One more small, unexpected way. This same ancient kingdom keeps turning up exactly where humanity happens to need it next. Fungi have quietly found their way into an entirely different modern discipline too, one most people never associate with mushrooms at all. Forensic scientists have begun studying the predictable sequence in which different fungal species colonize decomposing organic remains outdoors. Since certain species reliably appear only after a fairly specific amount of time has passed, careful documentation of exactly which fungi have taken hold and how far their growth has progressed can help investigators narrow down how long a body had been exposed to the elements, a discipline researchers have started calling forensic mycology. The same patient, decomposing talent that once quietly built the earliest soil on Earth, now helping modern investigators establish a timeline no other kind of evidence could offer quite as precisely. Fungi haven't only been welcome guests aboard spacecraft. In fairness, NASA engineers have spent real effort over the decades identifying and controlling mold growth that occasionally develops on interior surfaces of crewed spacecraft. The same basic organic material and enclosed humidity that makes a bathroom prone to mildew, turning out to be a genuine engineering concern at orbital altitude too. A small, slightly humbling reminder that this ancient kingdom follows humanity into space as both a helpful guest and, occasionally, an uninvited one. Notice your own breath again for a moment, wherever it's settled by now. There's nowhere left you need to be tonight, nothing left to hold onto. Just this same slow rhythm carrying you further toward rest with every quiet exhale. Not every fungal talent uncovered by modern science has been quite so welcome, and one deserves an honest mention precisely because popular fiction has recently made it famous. Cordyceps, a genus of parasitic fungi found in tropical forests, specializes in infecting insects, and one particular species has become genuinely notorious among biologists for hijacking an infected ant's own nervous system, compelling it to climb to a precise height and clamp its jaws around a leaf vein in its final hours before a fungal stalk erupts directly from the ant's head to release spores onto the unsuspecting colony below. A related caterpillar-infecting species, harvested by hand across the high alpine meadows of Tibet and Nepal, has become one of the most valuable fungi on Earth for an entirely different reason. Prized in traditional Chinese and Tibetan medicine as a tonic for strength and vitality, and nicknamed by some Western journalists as Himalayan Viagra, this same parasitic cordyceps now sells for tens of thousands of dollars per kilogram, supporting the livelihoods of entire high-altitude harvesting communities and demonstrating, yet again, that even fungi's most genuinely gruesome biological talents have a way of turning into someone's livelihood eventually. That same prized caterpillar fungus briefly became a genuine subject of international sporting controversy. In 1993, a group of Chinese female distance runners shattered several long-standing world records by startling margins, and their coach publicly credited part of their training regimen to a tonic containing this same cordyceps fungus, among other traditional ingredients. The claim triggered years of skepticism and doping speculation from the international athletics community, though no banned substance was ever formally confirmed in the runners' program. And the episode ended up sending Western demand for cordyceps supplements soaring for years afterward. One more example of a fungus, already worth its weight in gold, suddenly becoming even more sought after. This time on the strength of an unproven claim rather than centuries of traditional use. It's exactly the genuinely unsettling biology that inspired the fungal pandemic, imagined in the video game and television series The Last of Us. And it's worth being clear about where fact ends and fiction begins. Cordyceps species are highly specific to individual insect hosts and pose no realistic threat of ever infecting a human being. Whatever a television writer's imagination might suggest, the real biology remains remarkable enough entirely on its own, without any embellishment needed at all. Fiction aside, fungi have genuinely broken into mainstream popular culture in recent years in a way earlier generations would have found fairly surprising. The 2019 documentary Fantastic Fungi introduced a mass streaming audience to time-lapse footage of mushrooms fruiting and mycelial networks spreading, narrated in large part by Paul Stamets himself, and helped spark a broader wave of public curiosity about mycology that shows little sign of slowing down mushroom foraging clubs, home cultivation kits, and amateur mycology forums, all swelling with new members eager to learn more about a kingdom. Most of them had spent their entire lives walking past without a second glance. Some of that same curiosity W.H. son once had to smuggle carefully back from a remote Mexican village now unfolds entirely out in the open every year in a small Colorado mountain town. The Telluride Mushroom Festival, held annually since 1981, brings together professional mycologists, foragers, artists, and researchers for a long weekend of guided forest forays, identification workshops, and open public discussion of fungi in all their forms: medicinal, culinary, ecological, and psychoactive alike. It's a considerably different world from the one that forced Ma'ari'a Sabi'ina's own ceremonies underground for 4 centuries, or that drove W.H. son's own research into total secrecy for a decade. A once forbidden, once sacred subject, now drawing an entire town's worth of ordinary, openly curious visitors every single year. After everything else this kingdom has quietly built, fed, healed, and even flown into orbit tonight, what does it actually mean that one single species among it still works so patiently to end a life? Even the death cap's own quiet cruelty, met earlier tonight, turns out to have a genuinely precise biological explanation once modern biochemistry looks closely enough. Its amatoxins work by specifically disabling an enzyme called RNA polymerase Roman II inside liver cells, an essential piece of machinery every cell needs to read its own genetic instructions and keep producing the proteins it depends on to survive. Once that machinery stops working, the cell simply can't sustain itself any longer. A slow, silent shutdown happening at the molecular level, hours before any outward symptom ever gives the danger away. Set that single, patient danger against everything else this same kingdom has quietly done, and the balance tips overwhelmingly toward the side of a keeper rather than a destroyer. For every death cap working its slow, silent damage, there are countless other fungi busy decomposing, feeding, healing, and building. An entire ancient, patient kingdom that has spent well over 1 billion years mostly just trying to keep the rest of life on this planet fed and standing upright. And so, after everything, we find ourselves back where we started tonight, beneath an ordinary patch of forest floor, looking at the same vast, quiet network we opened with. Only now, you know a little more about what's actually down there. A kingdom of life older than nearly anything else alive, closer kin to you than to any tree, patient enough to have built the very soil the rest of life stands on, resourceful enough to survive inside a nuclear reactor, and humble enough that most of it will spend its entire existence completely unseen, doing its quiet work just beneath the surface of everything else that happens above it. They couldn't have known, any of them, from the Ice Age forager pressing mushrooms between her teeth to the pharaoh locking his away, from Ma'ari'a Sabiina opening her door to a curious stranger, to the researchers who found a single living thing spread quietly across an entire forest, that they were all touching different threads of the very same ancient, patient organism. A kingdom that built the ground under our feet before there was anyone to stand on it. And that's still, tonight, doing exactly the same quiet work it's always done. That's really the whole of what we've been following tonight. All the way from a billion-year-old split in the tree of life to a nuclear reactor in Ukraine. One continuous, patient thread running underneath nearly everything else that's ever happened above ground. Wherever you are right now, there's a version of that same quiet network resting somewhere beneath you too, doing its slow, invisible work, asking for nothing in return. Let your shoulders rest fully now, however they are arranged, and let your breathing keep finding that same slow, unhurried rhythm we started with all those hours ago. There's nothing left to hold onto tonight. No date, no name, no thread left dangling. Just the quiet, patient weight of something ancient, still growing gently beneath everything else, all the way to this exact room, this exact breath, this exact moment of rest. Sleep